Okay, this topic will cover on the subtopic of series of natural numbers and the sum of infinite series. So we have a natural number set of 1, 2, 3, 4 and dotted and rest. So we will try to get a formula sum for the following. For example, we have an notation sigma of r equal to 1 until n with the equation of r. So we'll get 1 plus 2 plus 3 plus 4 dotted until plus n. What happened if r square, we will get 1 square plus 2 square, 3 square and n square, and the r power of 3 equal to 1 power of 3, 2 power of 3, 3 power of 3, 4 power of 3 until n power of 3. So for formula and the equation of r, so 1 plus 2 plus 3, so we know it become a 1 over 2 and n plus 1. So now we want to show you how we can prove this thing. Okay. For example, we have for formula of, so we have, in order for us to prove of the formula, which is 1 plus 2 plus 3 plus 4 until n, so the formula just is equal to r equal 1 to n, for r is equal to 1 over 2 n plus 1. So we want to prove it. Okay, so we have a summation of r equal 1 until n for r. So here we have 1 plus 2 plus 3 plus until n. So we know this one is a arithmetic series. So when an arithmetic series, we can use the formula of Sn, where is 1 over 2 power of n times m 2a plus n minus 1 d. So we use this one. So we know here is 1 over 2 or n over 2 times, okay, 2 times a is 1 plus n minus 1 times d is 1. So here you will get n divided by 2 times n plus 1. So at the end we will get 1 over 2 n plus 1. So this shows that proof with the equation. Okay, so what happened for r square? How to prove it? For example, the formula that we want to prove is r square. So we have 1 square plus 2 square plus 3 square until n square. So the equation is r until 1 to n, r square is equal to 1 over 6 n. Okay, n plus 1, 2n plus 1. So how to prove this is the final equation for r square? So you can say it to prove it. So we use r plus 1 power of 3. So means this one will be r power of 3 plus 3r power of 3 plus 3r plus 1. Okay, so we use this one. So we can return this one to become r power of 1 power of 3 minus r power of 3. So on the right side we will have, this one is power of 2, 3r square plus 3r plus 1. Okay, if we want to, so if r equal to 1, so automatically we know that the left side is 2 power of 3 minus 1 power of 3. On the right side will be 3 times 1 power of 2 plus 3 times 1 plus 1. Okay, so if r equal to 2, so we will get 3 power of 3 minus 2 power of 3. So on the right side will be 3 power of 2 power of 2 times plus 3 2 plus 1. Then if r equal to 3, we will get 4 power of 3 minus 3 power of 3. On the right side we will get 3 power of 3 power of 2 plus 3 power times 3 plus 1. So here we notice that each of the equation is, there is a relationship which is 2 power of 3, this is negative 2 of 3, this one can be cancelled actually. So we keep on cancelling off here and here. So if we put this one in term of n number, so we'll get r equals to n minus 2 so if r n minus 2, so equal to n minus 2 will be n minus 1, got r plus 3 plus 1 so means just now r plus 1, so n, if n minus 2 we will get n minus 1 power of 3, okay, minus n minus 2 power of 3. On the right hand side you will get 3 n minus 2 power of 2 plus 3 n minus 2 plus 1. What happens if r equal n minus 1? So you will get n power of 3 minus n minus 1 power of 3. So on the right hand side you will get 3 n minus 1 square plus 3n minus 1 plus 1. Then if you have r equal n, so we'll get this one is n plus 1 power of 3 minus n power of 3 equal to 3 n power of 2 plus 3 n plus 1. Okay. So if we sum all of the equation of left and right hand side, so we know here this one can be cancelled first. Okay, this one will be cancelled, this one and this one will be cancelled. So if we sum it left and right, so what is left is n minus 1. So this one will remain is, if left hand side and right hand side we sum, what we'll get on the left hand side we'll get n plus 1 power of 3 minus 1 power of 3. This one we sum this one, so we have n, this one also we cancel and cancel, and above of this one will be cancel, so we'll get n power of 3, which is this one, which is this one, then minus 1 power of 3. On the right hand side, we will get the summation of r equal 1 power of n, where is your 3r square plus 3r plus 1. So here we can get is separate one by one, 3 with the sum of r equal to 1 until n, r square plus 3 constants outside, r equal to 1 to n r, and plus of r equal to 1 to n 1. So at the end you will get 3 summation of r equal to 1 to n r square plus 3 r equal to 1 and r plus n. Okay, so we make it everything on the left side. We will get n plus 1 power of 3 minus 1 power of 3 minus 3 summation of r equal to 1 and r minus n. You will get 3 summation of r equal to 1 to n r square. Okay. So this is our equation. Then we want to prove it. For example, we solve it one by one. So the right hand side, we put it in the left side, which is 3 summation of r equal to 1 r squared. This is what we want to prove. So the right hand side will be this one, means that n plus 1 power of 3 minus 1 power of 3 minus 3 summation of r equal to 1 and r minus n. Okay, so what you will get, so we'll get, for example, we take for our number, so this one will be n power of 3 plus 3n power of 2 plus 3n plus 1 minus 1 power of 3 is 1 minus term of the series of r 3 1 over 2 and plus 1, which have been shown you previously, minus n. So here you will get n power of 3 plus 3n power of 2 plus 3n plus 3n I think this one should be a 2 here. No, 3n, 2n here. So this one is 2n. Sorry. Correct. 3n. So it's 3n. So we know 3n minus 3n will be 2n here. Here is 2n. 1 plus 1 is will be 0. So remain minus 3 1 over 2 and plus 1. Okay, so we expand this one. We have n power of 3 plus 3n power of 2. Okay, plus 2n minus 3 over 2n square plus n. So here you can take out 1 over 2 outside, so what we'll get is will become 2n power of 3 plus 6n power of 2 plus everything will be times 2 with 4n, okay, minus this is remain 3n square minus 3n. Okay, so here you will get 1 over 2 power of 3 is 2 and power of 3, then you have this one minus this one will be plus 3 and power of 2 plus n. So you can take out the n, you will get 1 over 2 and 2 and power of 2 plus 3 and plus 1. Okay, this one you can factorize it, become 1 over 2 power of n, become 2n plus 1 and n plus 1. So now you will get so remember previously you have 3 summation of r equal to 1 and r square equal to 1 over 2n 2n plus 1 and plus 1. Then you put your 3 from left to right, you will get 1 over 6 and 2n plus 1 and plus 1. So it shows it's proven. Okay. Okay, how to prove for r power of 3? Okay, so we have a formula of summation r equal to 1 and r power of 3 is equal to 1 power of 3 plus 2 power of 3 plus 3 power of 3 plus n power of 3. Then we know the equation is r power of 1 and r power of 3 is equal to 1 over 2n n plus 1 square. How to prove it? Okay, so in this case we will use r plus 1 square minus r minus 1 square equal to 4r. So then if we multiply everything with r square, so we will have r square r plus 1 square minus r square r minus 1 square equal to 4 power r power of 3. So we already have power of 3 here. So now the same concept, we do the test or if test. So if r equal to 1, so your left hand side will be 1 square, 1 plus 1 is 2, 2 power of 2 minus 1, 1 minus 1 is 0, 0 power of 2 is equal to 4, 1 power of 3. And if r equal to 2, you will get 2 square times 3 power of 2 minus 2 square times 1 power of equal to 4 2 power of 3, then equal to r power of 3 is equal to 3 square power of 4 power of 2 minus 3 power of is equal to 4 3 power of 3. So if you have r equal to n minus 2, so the solution will be n minus 2 power of 2 times n minus 1 power of 2 minus n minus 2 power of 2 n minus 3 power of 2 is equal to 4 n minus 2 times 3 power of 3. Okay, then if we have r equal n minus 1, so we'll have n minus 1 square times n square minus n minus 1 square n minus 2 square is equal to 4 n minus 1 power of 3. So if you have r equal to n, so you will have n square n plus 1 square minus n square n minus 1 square is equal to 4n power of 3. So if you can see, the pattern is the same, which is for example, this one and this one will be keep on cancelling. Same, this one and this one keep on cancelling. So when we sum left and right, okay, so we sum left hand side and right hand side, what we'll get is n square n plus 1 square, okay, minus 1 square 0 square. Our right hand side will remain equation of r equal to 1 for r power of 3. So what you will have, for equation of r equal to 1, r power of 3 is equal to n square n plus 1 square. Okay, so we have the equation of r equal to 1, r power of 3 become 1 over 4 of n square n plus 1 square. So here we can put it to be 1 over 2 square n square n plus 1 square. So this one we will get 1 over 2 n plus 1 square. So it okay, this is how r square equation, r power cube equation, and also summation of r. Okay, we go for some of example. So we already proved that, so you can remember how I can understand and remember the step and also the final equation. So the question is, for example, find the sum of following series. Okay. So for example, A for A1. So we have summation of r equal to 1 and 2r minus 1 r. Okay, so this one you can see it can be r equal to 1 and okay 2 2r square minus r, so you will be 2 summation of r equal to 1 and r square minus summation of r equal to 1 and r. So you will get 2 1 power of 6 and n plus 1 2n plus 1 minus 1 over 2 and n plus 1. This is the formula that we get it from above proof. So here just put the equation here, you can get it, then you can cancel the 1 over 3 n plus 1 2n plus 1 minus 1 over 2 and n plus 1, then you will get take out everything, you will get 1 over 6 n plus 1 so you will get times factorize, it become 2n plus 1 minus 3. So then you will get 1 over 6 and n plus 1, this one 4n plus 1 minus 3, 4n plus 2 minus 3, so you will get 1 over 6 and n plus 1 4n minus 1. So this is your calculation. Then we can put it, so the question is asks for okay, find the following and if this one is 30 until 30. So you have already the equation, so we know that your equation, for example, is r 1 to 30 of the 2r minus 1 equation. So you just put it, your n is 30, you have 1 over 6 times 30, 31, okay, 30 plus 1 times 30 times 420 minus 1, so 120 minus 1. In the end you will get, the final answer is 18445. Okay. Okay, next example, we have B example. So we have, this question is summation of r equal to 1 for n, which is your 3r plus 2. So this one you can simplify it, become r equal to 1 to n, which is 3r square plus summation of r equal to 1 to n to r. Okay, so we just put the equation. The first one will be 3 times the equation for r square is 1 over 6, okay, n n plus 1, 2n plus 1, okay, plus 2, equation of summation of r is 1 over 2 and n plus 1. Then you open everything with 1 over 2 and n plus 1, 2n plus 1 plus n plus 1 equal to n plus 1, 1 over 2, 2n plus 1 plus 1. So you will get your equation of n plus 1 equal to, solve this one, you will get n plus 3 over 2. Then last one, if you simplify, it become 1 over 2n, n plus 1, 2n plus 3. Okay, so the question, if what happen if the summation of r equal from 10 to 40, which is your equation is r, 3r plus 2. So what you need to do is, so the first one you will have from r equal to 1 to 40. For the equation of r, 3r plus 2, then minus, second is r equal to 1 to 9, so is r, 3r plus 2. So you just put all the equation with 1 over 2, 40, 41, 80 plus 3, 83, minus 1 over 2, 9, 9 times 10 times 20, 18, 2 times 9, 18, 18 plus 3, 21. Right. So at the end you will get 68060 minus 945, then you get 97115. Okay.